Hi guys, this is Mrs. Stott here. I know I couldn't be with you today, but I decided to video my lecture so that you could make sure that you're on track for our test this week. So the two warm-up questions have to do with density and conversion, so you're going to need your calculator for sure. So go ahead and take that out. And then for today, you can either watch my video in one screen and type into the PowerPoint on the other side, or you could just take your notes on a piece of paper. But either way, this is going to be on the test on Thursday of this week, so you're going to make sure that you know this, of course. All right, here we go. So the two warm-up questions are up here. You can pause me while you work on the questions, because otherwise I'm going to go ahead and go through it. So the first one says, what is the density in grams per milliliter of a substance that has a mass of 6.27 kilograms and a volume of 1.5 times 10 to the third milliliters? So first up, I'm going to identify my variables. So I have my density equals grams, or equals question mark, and then it's going to be in grams per milliliter. My mass right now equals 6.27 kilograms, and my volume equals 1.5 times 10 to the third milliliters. So I check out my problem here, and I realize that the issue that I have is that my density is, we want it to be in grams per milliliter, but our mass right now is in kilograms. So we want to make sure that we go ahead and convert this kilograms. So in order to do that, I'm going to do 100 or 1,000 grams on top and 1 kilogram on the bottom, which is going to give me 6,270 grams. And again, you could have this in scientific notation if you want. And then I check it out and I have grams in one and milliliters in the other unit, and that's what I'm looking for. So now I can go ahead and plug it in to D equals M over V. So I have 6,270 grams divided by 1.5 times 10 to the third milliliters, and my final answer is going to be rounded to the lowest number of significant figures of my given, which is going to be 1.5. So my final answer is 4.2 grams per milliliter. If at any point you needed to back up, just realize that it's a video, so you can do that. So for the second one, it says, what is the density in grams per milliliter for a substance with a volume of 890 liters and 24 kilograms? So just right off the bat, once I go ahead and identify my variables, I see that there's actually two issues. So my density, we want it to be in grams per milliliter. My mass is in kilograms, and my volume is in liters. So we're going to go ahead and have to convert both of those before we plug them in. So just like in the first warm-up question, we're going to do the same thing for the kilograms to grams. So we're going to do 1,000 grams divided by 1 kilogram. That's going to give us 24,000 grams. For my 890 liters, it's a similar conversion. We want to get to milliliters. So we're going to do 1,000 milliliters divided by 1 liter. It's going to give us 890,000 grams. And then we're all set to plug in since we have the same units. Again, you could be in scientific notation here. It's going to give you the same answer. And I rounded to the lowest number of significant figures, which is from our 890 liters. That's going to be 2. And we get 0.0027 grams per milliliter. So if you're all set with that, let's go ahead and move on. So your homework, on today, you should have picked up a worksheet, or you should have gotten a worksheet from the teacher. So if you haven't done that, you might want to remind them. And that worksheet will be due on Wednesday. Lab tomorrow on Tuesday for periods 8, and you want to make sure that you have your pre-lab and post-lab due. So I'm out for an appointment today, so I will definitely be there tomorrow for our lab. And then the lab on Friday for period 7. Same thing. And then keep in mind we do have a test this week. I don't have it on here because I just wanted to kind of give you the most recent deadlines that you want to kind of keep in mind. But the test is on Thursday, so we're going to want to make sure that we are prepared for that as well. All right, so we're going to talk about temperature conversions today. It's only going to take me about 10 minutes, if that, and then you are going to be working on a portal quiz, which I'll talk about in a second. And then if you finish that up, you can work on your homework, which is the worksheet. All right, so there are three different major temperature scales, and we've kind of talked a little bit about this year so far. So we have Fahrenheit in this first picture. This is the one that we use, so we know that the freezing point in Fahrenheit is 32 degrees, and then we know that the boiling point of water in Fahrenheit is 212 degrees. And then we have Celsius is going to be 100 degrees Celsius for the boiling point, and 0 degrees Celsius for the freezing point. And then we get over to here where we have Kelvin. Kelvin is primarily used with gases and just in like chemistry and physics problems generally. But we have the boiling point is actually 373 degrees Kelvin, but actually we just say 373 Kelvin. And then for the freezing point, it's 273 Kelvin. So notice there's no degrees sign over there. So that's purposeful. Just another way to think about this, and also just some interesting things. So I know that on the summer packet, I actually asked you about absolute zero, and it's where all molecular motion stops. So that's going to be 0 Kelvin. That's what Kelvin's kind of representing. Then we have negative 273.15 degrees Celsius, and then negative 459.67 Fahrenheit, which is super, super cold, as I'm sure you can imagine. Okay, so here are our conversion factors for temperature. There are a bunch. You are not going to need to memorize these, just like the conversion factors that we've seen before. However, they are a little bit more complex than what we've seen. So in that first one, we have Fahrenheit. So whatever we're looking for over here with the question mark. So to get from Fahrenheit to get from Celsius to Fahrenheit, we're going to use the first one. So the number of degrees C, that's what we would be plugging in the given. For converting Fahrenheit back to Celsius, we're going to do the number of Fahrenheit, here's our given, minus 32, and then we multiply it by this proportion. And then Kelvin to Celsius is much easier. So if we're going to go Celsius to Kelvin, we're going to just add 273.15 to the already existing given of Celsius. And then if we want to go the opposite direction, so back to Celsius, then we would do Kelvin minus 273.15. So we're going to use those. So feel free to write those down, or again, you could just get them from the PowerPoint if you're working on that. All right, so it says liquid oxygen boils at normal pressure, just kind of some extra information, at negative 182.9 degrees Celsius. What is the temperature in Kelvin? So we're converting here from Celsius to Kelvin. So I'm going to use the equation K equals degrees Celsius plus 273.15. Then I'm going to plug in my given as I'm given it. And then we're just going to solve. And then I rounded to the number, today I'm just going to round to the number of significant figures of our given temperature. So we're going to end up with 90.25 K. And that's because we don't really want to round temperatures too much because we're talking about temperature and it's kind of a specific thing. And I'm going to put a box around my answer. Notice that the temperature was negative in Celsius, but it's not in Kelvin. So that's something that you'll find with temperatures. Just because it's negative in one doesn't mean that it'll necessarily be negative in another, just because of the way that they are proportionate to each other. All right, heavy water contains the heavy form of hydrogen called deuterium, whose atoms each have one proton, one neutron, and one electron. Heavy water freezes at 38.9 degrees Fahrenheit. What is the temperature in degrees Celsius? So this one's a little bit more complex, so the Fahrenheit to Celsius is a little bit trickier. And same thing for Celsius to Fahrenheit. So we have degrees Celsius equals Fahrenheit. This is going to be the given one right here, minus 32 degrees Fahrenheit times 1 degree Celsius divided by 1.8 degrees Fahrenheit. So I'm going to plug in my given of 38.9. And then I'm going to solve this first set of parentheses first. So I ended up with 6.9. I didn't round or anything. And then I'm going to multiply it by 1 degree Celsius over 1.8 degrees Fahrenheit. And then we're going to end up with Fahrenheit's units canceling out. I'm going to round to the sig figs of the given, which is 3, because it's 38.9, and then it's going to end up with 3.83 degrees Celsius as our final answer. All right, last but not least, the compound 1-chloropropane, and then it gives us the structural formula, which we'll talk about later this year, melts at 46.6 degrees Celsius. What is this temperature in Fahrenheit? So now we're going from Celsius to Fahrenheit rather than Fahrenheit to Celsius. So we have a similar equation to the one that we saw before, but it's kind of backwards. So we have the given in Celsius times 1.8 degrees Fahrenheit divided by 1 degree Celsius plus 32 degrees Fahrenheit. So I'm going to go ahead and plug in. Oh, my screen, of course, skipped a step, but we're going to go ahead and plug in. So we have 46.6 plugged in for the given. And then what I did is I solved for the two sets of parentheses here. So I did that first for order of operations. So I got 83.66, didn't round yet, plus 32 degrees Fahrenheit. I went up to the original and it had 3 significant figures up here in the 46.6. So I got 116 degrees Fahrenheit as my final answer. Okay, so once you feel good about that, again, you can always rewind. You can go back and pause it at certain parts to make sure that you get the notes for that. There is a quiz on the portal that you must complete by 2:30. So it stops collecting responses at 2:30. So obviously you're going to want to make sure that you do it now. And it is going to be for credit, so you want to make sure that you're doing your best as well. If you finish that, then you can go ahead and move on to working on the worksheet, or you can work on your lab notebook since you know that you're going to have that this week. So again, right now you're going to go on the portal quiz and you're going to complete that quiz. You're going to make sure that you do your best because it's it's going to give you credit for it. And it does shut off at 2:30. All right, guys, I will see you tomorrow.